Topic for today is logical operators. So what are logical operators? There are basically three logical operators that we usually use in the computer programming. The first one, AND. The second one we use is OR. And the third one is NOT. Now the question is, why do we need logical operators? As you guys have seen, we have studied conditional statements in if-else blocks. We also studied relational operators, which are used to create those conditional statements. However, what we have not seen is if you have multiple conditional statements and you want to join them together, that's what is the job of logical operators. So let's go ahead and start with our AND operator and see what properties does it hold. So now coming back to our example of roller coaster, let's suppose we have a ride which is meant for kids only, and there are three criteria for people to ride that roller coaster. The first criteria is that the age needs to be less than 10-year-old, right? The second criteria is the weight needs to be less than 50 pounds, right? And then the third criteria is the height needs to be less than 48 inches, right? So based on these three criteria, we can determine who can and cannot ride the roller coaster, which is really meant for kids. And let's suppose we don't have these logical operators available. How are we going to write this situation? We will have an if statement which says age is less than 10, right? But this is not the only criteria we're checking. Now, if this criteria is met, we will go ahead and check the next criteria, which says weight is less than 50 pounds. But again, that's the second option, the second criteria. The third one we have to check again inside is height is less than 48 inches. Now, if all these three criteria are met, then we can go ahead and say that this person can ride, correct? But if any of these criteria is false, we are not going to allow that person to ride the roller coaster. So we have to put else statements cannot ride. Now the thing you'll see here is we have to write these else statement for each one of this if block. This else belongs to this if, this else belongs to this if, and this else belongs to this one. Now let's consider a scenario where we have somebody whose age is 8, whose weight is 60, and whose height is 60 as well. All right, so what's going to happen in this case? The execution is going to come here. Age 8 is less than 10. This will be true. Weight 60 is less than 50, which is false. So since this is false, it's not going to come inside and evaluate this if condition. It's going to go ahead and go here, and it says print cannot ride. Okay? Now let's suppose we have a situation where the weight is 40 and height is 60 again. So in this case, this evaluates to true. It's going to go ahead and execute this one, which evaluates to true as well. It's going to go ahead and execute this one, and this evaluates to false. So it's going to follow this else to print cannot write. Okay, That's why we need else with each of these, because if any one of them turns out to be false, it's going to execute the else that is associated with that if block. So there is redundancy here, right? And this is more difficult to follow the logic. It's more difficult to understand. We can simplify it quite a bit if we use logical operators. So let's go ahead and use the AND operator to simplify this whole execution. All right, so now that we have seen the nested if-else statements and how complicated it is to understand the logic and to get it right, we can simplify that logic very easily using the AND operator. But first, we have to see what are the properties of the AND operator, okay? Now, in order to understand the properties of AND operator, let me just start off with the fact that if you have a Boolean expression, let's call it Boolean expression 1, and you have another Boolean expression, let's call it Boolean expression 2, we can compare these two Boolean expressions using the AND operator. Okay, so in Python we write lowercase and. Again, this is dependent on the language that you're programming. So if you're in some other language, they may have a different operator. Let's suppose we have this table. We say Boolean expression 1 here, Boolean expression 2 here, and the result of combining these two Boolean expressions with an AND. So if this Boolean expression evaluates to true, okay, and the second Boolean expression evaluates to true, if you combine it with AND, it's going to result in true. Now if this Boolean expression 1 is true and Boolean expression 2 is false, this will result in false. If Boolean expression 1 is false and Boolean expression 2 is true, then the result will be false. And if both the Boolean expressions are false, then the result will be false. So this is the property, or you can say truth table, for an AND logical operator. Okay? So keep that in mind whenever you're combining multiple Boolean expressions using the AND operator. Right? Okay? So what does that mean? That means if the only time AND will evaluate to true is when both the Boolean expressions are true. If any one of them is false, AND will evaluate to a false result. Alright, so now that we understand the truth table for AND conditional operator, let's go back to our previous example where we were evaluating nested if-else conditions and see how we can simplify it. So again, let's suppose we have a program which evaluates a person who wants to ride a roller coaster which is meant for kids, and it takes into account age, weight, and height. Let's see how we can simplify the nested if-else logic that we had in the previous example using the logical operator AND. So if age is less than 10 and height is less than 48 and weight is less than 60, right? Then we go ahead and we say print ride, else we print cannot ride. Now, this is exactly the same as our previous example of nested if-else blocks. Now, if you see here, it's very easy to follow the logic. It's much shorter code, less lines of code, which is always better. So what this if statement is telling us is that when age is less than true and height is less than 48, so both these have to be correct, then it will go ahead and evaluate weight. And so all three of them have to be correct or have to evaluate to true in order for it to satisfy this whole Boolean expression and evaluate it to true. Only then it will go ahead and print that the person can write. Otherwise, it will say cannot write if any one of this is false. All right. Now, it's important to understand that in terms of evaluation, it will first evaluate these two. So let's suppose if age of the user is 8 and his height is 60 and his weight is, let's suppose it's 50. Okay. Now what is it going to do is it will say 8 is less than 10 and height is less than 48. It will evaluate these two first. So this will evaluate to true and this will evaluate to true. Now we have seen from our truth table that if true and true, it's evaluated to true. So the result of these two evaluations will be true. Let's go ahead and replace it here with the result of these evaluations. So this will be true as a whole. Then it will go ahead and evaluate weight. So in this case, weight is 50, which is less than 60. Now this will evaluate to false. Okay, so this will evaluate to false, but on this side we have true. And based on the truth table, true and false will evaluate to false. So the result of this whole Boolean expression will be false. That's why it's not going to print can write. Instead, it will go ahead to this statement and say print cannot write. Now, if we had a case where the weight is 80 pounds, then it will go ahead and evaluate this one to true. And since both the sides are true, the result will be true as a whole. It will go ahead and print the right statement. So that's how we combine if statements, nested if statements using AND operator and make it more simple for others to understand and for us to understand. Now, one thing that is very important is this. There's something called short circuit. Now, what does it mean by short circuit? Let me try to explain it through an example. Suppose if the user's age is 12, okay? When this is compared, 12 is less than 10, which evaluates to false. So this will evaluate to false. Now, when this evaluates to false, so based on our truth table, if any of the Boolean expression is false, the result will be false. So there is no point in evaluating these two statements, because even if these two statements turn out to be true, our overall result will be false. So the computer says, why bother evaluating these two statements? And that's what is called short circuiting. So you have to keep this in mind when you're writing your programs. So there's a possibility that these statements will never be evaluated based on the result of the first one, just because of this concept called short circuiting.